Welcome to VCF Automation 9 video series. My name is Mahar Al-Asfar and I am a product marketing engineer within the VMware Cloud Foundation division at Broadcom. This is part 4, virtual machine self-service consumption of this video series. We'll start first by touching on our VCF 9 infrastructure setup and the organization tenant design that we have implemented so far. Now that we have access to the infrastructure core services, such as the virtual machine service, after configuring our organization as we have seen in the previous videos, we can demo how to provision a basic virtual machine using the virtual machine service. And then we'll move on to demo provisioning a virtual machine using more of the advanced options. So let's get started and dive right in. If you watched the previous videos of this series, you should now be very familiar with our lab setup and the organization design that we have implemented so far. If not, I would encourage you first to go and watch the previous videos in this series before moving on. Our VCF 9 demo environment includes one management workload domain and one VI workload domain or virtual infrastructure. Each domains have dedicated vCenters and NSX managers, and we have the edge clusters are deployed and configured with Border Gateway Protocol or PGP to enable dynamic routing in both the domains. We have also a supervisor deployed in each of the domains. These supervisors are configured with VCF networking with VPCs and have dedicated external IP blocks to enable external connectivity. Across the two domains and on top, we have VCF Automation, which we have configured with two regions. Region US West includes the supervisor in the management domain, and region US East includes the supervisor in the virtual infrastructure workload domain. Within VCF Automation, we also enabled the provider consumption org when we called it ACME. ACME is an all-app organization that is configured with two region quotas, one coming from each of the regions, US West and US East. Also, the all-app organization ACME is configured with dedicated external IP blocks for external connectivity for each of the regions. All the external blocks do not overlap with each other. Within the ACME organization, we have a project called Core Stack that is configured with two vSphere namespaces. We have ACME Dev in the US West region, therefore it's created on the supervisor in the management domain, and then the ACME Prod namespace in the US East region, therefore it's created on the supervisor in the VI workload domain. For this demo, I am already logged into the VCF Automation organization portal as the organization administrator. You also could be connected here as the developer or the user. On the overview page, we can see the number of projects we have access to and the number of namespaces, and of course, access to the services that we have enabled. To provision a virtual machine, we can either click on the virtual machine service or on the services overview, which takes us to the summary page of the ACME development namespace. We have a namespace selector here for the Core Stack project where we can select the destination that we want. We will stick with the ACME development for now. Here we have access to the services and the service tiles, and we can interact with the virtual machine service. We can either click on Create VM, which will take us to the workflow, or click on the Go To service, which will take us to the virtual machine service under Services. Here we see a list of the available virtual machines that were deployed, and also be able to deploy and manage VMs in a self-service way. So let's go ahead and click on Create VM to create our virtual machine. This takes us to the new virtual machine workflow, and we can select the source type. We support OVF or ISO. OVF will have a lot more options available to us. So we're gonna select the OVF and click Next, and then provide the VM name. We'll simply call this basic since we're going to be provisioning a very basic VM. And then move on to selecting the zone. The zone by default is set to automatic, which means that the zone will be automatically selected based on the VM requirements. However, there's a caveat here that you cannot attach storage volumes if the zone is set to automatic. Therefore, if you're planning to attach additional disks, you want to select explicitly the zone where you want to provision the virtual machine, which we will see in the advanced demo. Moving on to the template that defines the guest operating system, which we call VM image. So we're going to select Ubuntu 2404 and then move on to select the virtual hardware specification, which we refer to as the VM class. And we'll select best effort extra small. This is going to configure our virtual machine with 2 virtual CPUs and 2 GB of memory with no CPU and or memory reservation. Moving down, this is the available storage class, which is the vSAN backed storage. And then the power state, of course, we want the VM to be powered on. At this point, I can go and actually click on review and configure and go ahead and deploy the VM. While the VM would successfully deploy, I will not have any ability to access it because Ubuntu cloud images usually are built with the assumption that the cloud init or another metadata provider will inject a user account or SSH keys or the initial configuration. So if we boot one as is from here without the cloud init and metadata source, we'll probably have no password set for the default Ubuntu user. SSH may be installed, but you can't log in because there's no authorized key or password set. And on some images, and especially Ubuntu, the root login is disabled by default. So what we need to do at a minimum, go to advanced settings and scroll down to the guest customization section. And for simplicity, we're gonna use the guided inputs. So for this, we can go and select our time zone, enable the default user, which is the Ubuntu user. You have the option to create a new user, but we'll leave that for the advanced demo. And here you can see on line 14 that there's a section called Bootstrap now, where we include our Bootstrap configuration. To be able to use the Ubuntu built-in default user account, we also have to provide our public SSH key so it can be injected into the virtual machine and then be able to use our private key to access the VM. And then the last thing here, we want to enable SSH and then move on to run just simply any commands we want to execute when the VM is bootstrapped. So here what we're going to do is we're going to access and update the apt repo and then install the tree package and then do an echo that says bootstrap complete, grab the date and pipe that into a log file under the temp folder. Everything that we've done through the workflow has been generated in the Kubernetes resource YAML that we see on the right-hand side. Here we can go and download this YAML to a zip file or copy the content. So we can save it into a source control repo like GitHub or GitLab, or use it with CD tools like Argo CD, or even use the command line to create this virtual machine or modify the YAML to provision newer virtual machine. We'll click next and move on to the network configuration. By default, the network interface will be connected to a private subnet. So this is a private VPC subnet that currently I will not be able to reach from the machine I'm doing the demo on. Therefore, what I want to do is use the same Ethernet, but instead of using the private subnet, I'm going to use the public subnet, which will allow the VM to be configured with an IP address I can connect to. We'll hit save and move on to the global network setting. This is where I can specify my domain name and my search domains I want to use, as well as use the DNS server that I want to configure the VM with. Moving on, we'll hit next, and now we're ready to review and actually confirm and deploy our VM. And we can see on the top banner that the virtual machine VM basic is being created. If we quickly switch to the vCenter, we can see that the VM is VM basic has been created under Acme development, and currently it's being deployed from the OVF template. And then we'll give this some time until the VM is powered on and bootstrapped. Okay, so we see the VM is booted and it has an IP address right now, and the DNS name is set. And if we scroll down, we see the VM hardware. It's configured with 2 virtual CPU and 2 gig of memory, and it's connected on the public subnet. Let's switch back to VCF Automation. Usually the user don't have access to the vCenter. I'm just showing this to show you what's happening on the back end. In VCF Automation, under the virtual machine, within the virtual machine service, we can see that the VM basic VM that we provisioned has a ready status, and it's powered on, and it has an IP, and we can see the image it was provisioned from and the VM class it was configured with. If we click the double arrows, we see additional information in terms of the age of the VM and some of the labels, and access to the active YAML of the virtual machine. This basically have all the configuration of the virtual machine. This YAML also can be actively edited and saved, and that desired state then is applied. So let's go ahead and close this. Also, to access the console of the virtual machine, we can either use the remote console if you have that downloaded and installed. If not, you can use the web console, of course. Now, clicking on the VM basic takes us to the VM details. Here we can perform some day 2 actions like power on and power off the VM. And when the VM is powered off, we can actually go and edit the VM class, where we can use a larger VM size, for example, if you needed to. Scrolling down, we can see the network it's connected to, the IP address and the MAC address, and the host information and the DNS settings, in addition to the volumes. If you want to attach volumes as a day 2 actions, you can also do that. And also we see the conditions and the events that the VM went through. Let's go ahead and grab the IP address and actually try to log into the VM. So here I'm going to switch to my terminal, and I'm going to create a new SSH session that points to the IP address, and I'm going to use the default Ubuntu user. Now, to be able to use the Ubuntu user, I have to attach my private key and hit OK. And I'm going to accept the warning. It's going to authenticate with the public key, and now we have access to the database. If we try to cat the temp file that we've created, which is the bootstrap, we can see that the bootstrap completed on Monday, September 29th. This is the time of the recording. Also, if I go back to my folder, I can see that the tree package is installed, but again, I don't have any files here. What we can do is go up to the root folder and type the command that will show us the tree package has been installed. Again, for this demo, I'm already logged in, as I mentioned, into the VCF Automation organization portal as the organization administrator. You also could be connected as the user. And back into the virtual machine service, we're going now to show you provisioning a virtual machine with some of the advanced options available to you. Again, we'll click on Create VM, and we'll continue to use OVF because it has all the extra options available to us. And click Next. And here I'm going to call the VM Advanced and move on to selecting the zone. Because I want to provision as storage volumes, I have to explicitly select the zone that is backed by a cluster where I want to provision the VM, and then move on to select the OS that we want. I'm going to select this time Ubuntu 18 since I'm planning to deploy MySQL, an older version of MySQL. And if we scroll down, we'll continue to the virtual hardware. We're going to, again, select best effort extra small. So the VM is configured with 2 virtual CPUs and 2 GB of memory. Scrolling down, we'll use the vSAN backed storage by selecting the right storage class available to us. And then the power state is going to be powered on. Everything that we've selected so far has been generated in the Kubernetes resource YAML on the right-hand side. Instead of clicking review and confirm, we're going to go and click next so we can advance to the advanced settings. This is where we can attach persistent volumes, configure load balancers, and customize the guest OS of this VM. You can specify any additional disks here to be associated with the VM. We'll click attach volume. I can select from existing volumes that I've created in the past, but for this demo, we're going to create a new volume of 10 GB. On the same vSAN backed storage, and we're going to click save. The minute I create the volume, it's going to create a new Kubernetes resource YAML of type persistent volume claim, and it's going to be of read write once access mode. And as we can see, the storage size that we've selected on the backend storage using the storage class name. Scrolling down, a VM here can be exposed as a load balancer service. This load balancer will route traffic from the source port on the load balancer to the external port on the virtual machines that are configured as endpoints. Again, I can select existing load balancer if I previously provided or provisioned one and I want to continue to use that. But for this demo, we're going to create a new. I'm going to name this ADV or advanced at the end here. So I know it is associated with the VM I'm provisioning. And then here I want to be able to SSH to the VM. So the first port I want to create, I'm going to call SSH on port 22. And also the target is going to be same port 22 as well. And because this is going to be a MySQL virtual machine, I'm going to also create one port for MySQL. And this port is going to be 3306 on the port and the same target on the virtual machine. I'm going to add both and I'm going to hit save. Once I create the load balancer, a third YAML manifest gets created of type virtual machine service, where it documents all the ports and it has the selector, which matches the selector on the virtual machine. This is how the load balancer knows where or what VM to route the traffic to. And we can see both rules here, one for SSH and one for MySQL. Moving on to the guest customization. For this advanced demo, I am not going to use the guided input, and instead I'm going to use the raw configuration, which is an option available to you. So for you to just simply go in and dump the cloud config data that you have. So in this cloud config, we are updating the repo. We are installing the packages of MySQL of a specific version 5.7, which is quite old. And if we move on to the user, we can see the demo user is being created and also have the password for it and the SSH key as well. But if we notice in the command line, what we're doing also, we're modifying the SSH underscore config file, and we're enabling password authentication. So now we can actually log in with the private key or log in by just providing the password. And continuing with the command line, this is where we can go in and actually modify all the files we need, execute all the commands we need to create an open cart database, and then hit next. Since I have a load balancer exposing both SSH and the port for MySQL, I do not need to connect this to a public VPC subnet. So I'll continue to leverage the internal and default private subnet and then move on to the global network settings. Here, I'm going to provide my domain name and search name, and then also provide my DNS as well. So we're going to add our name server as well, and then move on to next. Now I am ready to review my configuration and the YAML generated in the viewer. As you can see here, now we have 4 different YAMLs, one for the virtual machine, one for the secret for our cloud init. This is where all the cloud init stuff is stored, which is a secret object. And then we have our load balancer and persistent volume claim. I can easily download all the YAMLs to a zip file where I can store this on a source control repo like GitHub or GitLab. So I can use it with continuous deployment tools like Argo CD, for example, or use the unified VCF CLI to deploy these objects or modify the YAMLs to deploy new objects. Once I'm ready, I'm going to go ahead and hit deploy VM. We can see the banner showing us all 4 components being created. We'll switch quickly to the vCenter, and we can see that the VM Advanced is created in the Acme Dev namespace, and then it's being deployed from an OVF. This will be now the 18.04 OVF since that's the OS image that we've selected and opted to deploy. We'll give this some time and wait for the VM to power on, which we see it did, and wait for it to have an IP address, and then we'll switch back to VCF Automation. All right, so we can see the VM is booted, and if we scroll down, we see the VM is configured with 2 CPUs and 2 GB of memory, and the network now is actually connected to a network called VM default, which is a private VPC subnet. Let's switch back to VCF Automation. We can see the VM Advanced under Virtual Machines is listed. It's ready, it's powered on, and it has an IP address, and you can see that the IP address configured here is different from the previous IP address that was configured to VM Basic when we connected it to a public VPC subnet. Since this is connected to a private VPC subnet, the IP address inside our subnet is different. It's configured from the Ubuntu 18.04, and we used best effort extra small VM class to configure it. Now, to access the virtual machine, I cannot simply grab the private IP address. So if we click on the virtual machine to go and access the VM details, we can see in the network services that it is associated with a load balancer, and this is the name of the load balancer. If we click on the load balancer, that takes us to the network service and to the service detail. And this is where I can see the ports that we've enabled and exposed on the load balancer, the different labeled assigned, and the target endpoint, which is the advanced virtual machine that we provisioned. I'm going to grab the external IP address of the load balancer and simply switch to my terminal. And this is where I can go in and create a new SSH session and be able to provision or access the virtual machine. This time I'm going to access it with the demo user that I've created using the cloud config. At this time, I don't have to go and attach my private key because I've enabled password authentication. So I'm going to click OK, and this will take us, we'll accept the warning, and then it's going to ask us what is the password. I'm going to provide the password here. And we can see that we've actually connected to the virtual machine as the demo user. And if we type MySQL, we can access the database, and if we try to show the databases, we can see that we've created an OpenCard application. This concludes part 4 of the VCF Automation 9 video series. Hope you enjoyed it. Thank you for watching, and see you in the next one.